Okay, let us see now moments when they are given in when the forces and then the point are given in vector form. Okay, we are going to start with this, then we shall reason. So this question says, find a moment about the origin, so not where. So they are telling us about the origin of the force. This is the force. You note the signs. Here the signs are important. Acting at the point. So this force here is acting at this point. So first of all, we first note out the point where this force is acting. So this force is acting at this point, 2, 2. So that our 2, 2 is here. So this is our point, 2, 2. Now at 2, 2, there is a force. You see that the horizontal component is a 4, but it's positive. So positive, we go in this direction. So this is where we have our 4. That's the horizontal component. Then the vertical component is positive, meaning it's going to go on this side. So this is our vertical component. So now we need to take moments now. They're telling us now this time we are taking moments about the origin. So this is our origin. So moments about the origin, you see at the origin, I'm going to take them clockwise. Why clockwise? Because you see, from here, this force, when I am at this point, I can take this force here, like this, or like this. It's up to you. Now I'm going to consider them clockwise. Now, at this point here, you note, we always note that we need always the force and then the perpendicular distance. Now, from the point where we are taking, this is our point O. So we are taking, so we need the perpendicular distance to this force here. Then we shall also need the perpendicular distance to this force. Now, if I consider the point of this force first, now is that the perpendicular distance from this point is going to be, you note this, you note that, and then you note this. The perpendicular distance for this force from the origin here, from here up to here, they are 2 units. Meaning, I'm going to say 4 is when I'm here. This force here is going to turn clockwise like this. So when I'm here, you look at that force, you see I'm going to be having, you see its perpendicular distance is going to be this. So when it's here, you see it's going to be acting clockwise. So I'm going to say 4. Now the perpendicular distance from here, now the perpendicular distance from here up to here, the same as perpendicular distance from here up to here. That's why I'm going to take here to be 2 units. The perpendicular distance is 2 units. Now, when I come now to the perpendicular distance of this, so that now this one is going to act anti-clockwise. I think you can see. When I get this force here, it's going to act anti-clockwise like this. But when I'm here, the perpendicular distance is the perpendicular distance, and the force is here. You see, for it is going to be acting clockwise. So that's why I get this 2, the perpendicular distance times this force. Then here, you see its perpendicular distance is here, so meaning it's going to act in that direction. So you say minus 3 times 2. This is going to be 8, which will give us 2 Newton units. Now these are units. Okay, these are units because we're going to have. So Newton units, then which direction? Clockwise. Because the difference is you can see clockwise. When you come to this, find the moment about a point A with the position vector. This is negative 1, 2. Negative 1, 2. This is now the point A. So our point A. Of the force, negative 2, 3, acting at 3, 3. Where is our 3, 3, 3? So the force is acting at 3, 3. 3, 3. That's where our 3, 3 is. Now this force is that the horizontal is negative, meaning it's going now to come beside negative. In that sense, then the vertical is positive. The vertical is positive. So this is going to be 3 newtons. This is going to be 2 newtons. Don't put negative because this is showing it's the negative. Okay. Of course, they are there. Now, we are taking them at A. Now this is the point where we are taking, so we are taking them now. When I'm at A here, I have this first, and I have this first. You see at A, if I consider the vertical component first, you see at A here, I'm going to need this perpendicular distance from here up to here. So you see this first, it's where you are going to take it anti-clockwise. So at A, we are going anti-clockwise. We base on the perpendicular distance. Now the perpendicular distance from here to this, you are going to see the perpendicular distance is going to be 1, 2, 3, 4. So we have 4 units. From here, this is the perpendicular distance to this. You see, this is going to be perpendicular to this. So from this point, so this point was negative 1, 2. So you count from here, that's the perpendicular distance. 1, 2, 3, 4. So you get the first, our sum is going to be the first 3 times the perpendicular we are taking, because this one is going to act. From here, it's going to act anti-clockwise. That's why I'm taking it anti-clockwise. The perpendicular distance is 4. Now, when I come to this, where is the perpendicular distance from here? This perpendicular distance is going to be here. But you see where this force is going to be. It's going to be like that. I think you see the direction this is going to take. It's also going to take anti-clockwise. From here, this is the force. Then the perpendicular distance is going to be here. I think you can see that perpendicular distance. Where is it going to act? It's going to act in this direction, as you see. You see? When it's here, it's going to act like that. So that's why I'm going to be having plus, now the first 2 times the perpendicular distance from here. You see from here and down, it's just 1 unit. 1, which will give us 13 Newton units. As simple as that. Be careful. When you come to this, find the moment at a point, about a point 2i. 2i means that we don't have, it's just the x is 2, don't have 1. So we have 2i. 2i, this is the point of our force. So this is our force, negative 2, negative 4. Acting at a point, so where is it acting? It's acting at a point, negative 2i. Negative 2, negative, this is where our force is going to be. Now it's acting, you see this one is negative, so negative in this direction. So here we have 2 newtons. Then you see that this one is negative, so meaning it's going to act downwards. It's going to be 4 newtons. So that's the point we have there. So now we are taking moments about this point, about a point A. Okay, let us just take this point here. So let us call it B. So let me call this point B. When I call it B, now I need to know, am I going to take clockwise or anti-clockwise? So from this point, you see, this one is going to go anti-clockwise. I think you can see the perpendicular distance of, you see this is the force. The perpendicular distance, when I write this distance, you see where it's going? It's going anti-clockwise, as you can see. What about this? Where is the perpendicular distance? The force is here. Where is the perpendicular distance? The perpendicular distance from this point is going to be this. So where will it act? If the point is there, it will act in this way. So meaning the bigger force is going anti-clockwise. Okay, anti-clockwise. Now mind you, I need the perpendicular for this. Now from this point, our force is there. So from this point, this is going to be our force. How many do we have? 1, 2, 3, 4. So we have, because it's going, this one is going to go from here, 1, 2, 3, 4. But it's going to go anti-clockwise. And we are taking also anti-clockwise, like this. So it's going to be, the force is 4 newtons, then times the perpendicular distance, which is 4. Then, when we come to this, where is the force? The force is there. Where is our point? This is our point B. I think you can see. what is the perpendicular distance from this point? I think you can see from here to this, it's going to be just 1 unit. But you see, for it, it's going to go, when I'm here, and I take moment there, for it, it's going to go anti-clockwise. I think you can see that. So that's why I'm going to say minus 2 times 1. This one, you see, from this point here, is 1 unit. This will give us 16 minus 2, which will give us 14 Newton units, and clockwise and clockwise. As simple as that. So that's it. Whenever you have that, all you need, if you come here, the point is here. Where is the force? Our force from this point is here. You see? That's why we are going anti-clockwise. Then when I come to this force, where is it facing? It's facing this side, from which point you see it was 1 and it still was going anti-clockwise like that. The same idea. When we came to this, we had 2. You see that the force was forcing in that direction. Where was it going? This one. If this is the perpendicular distance, it was going this side clockwise. What about this one? If this was the perpendicular distance, you see it was going anti-clockwise. As simple as that. So, that's it, members. I wish you well.